Hi everyone, this is Vamshi. I'm a data engineer. In this video, we'll be working on a PySpark portfolio project. We'll be solving 25 real-world problems using PySpark data frame API. We'll be using Northwind database in this project. This is a very popular and sample database provided by Microsoft. We will be using select, filter conditions, joins, group bys, and window functions. These are very essential commands a data engineer uses in their day-to-day life while working on big data. Let me provide the credit where the credit is due. This project is inspired or copied or whatever you want to call. This is taken from this channel, Curbal. She makes a lot of videos related to Power BI. If you want to learn Power BI, this is a great channel. She has a challenge called 25 days of DAX. You can clearly see here, where we'll be solving 25 questions using DAX. If you don't know DAX, DAX is a language used in Power BI. So she solved all 25 questions using DAX. So we'll be using the same questions, but we'll be using PySpark. And also I will make another video where we'll be using SQL to solve the same 25 questions. So if you go to her website, you can clearly see these are the 25 questions we'll be solving. You don't have to write all these questions. I already provided a code template with all the questions. You just have to solve the questions. So if you go to my GitHub page, I will provide the link in the description for the channel and also for my GitHub page. Go to this page and go to code and download. First of all, to download the zip, I'll download it. So download it. Okay, let me download it again. Download it. So let me remove this. After this, extract it. Extract here, and then delete it. So if you go to data, these are the 5 tables we'll be using in this project. So if you go to code template, this is the Power BI file. This is a Power BI file she provided. We won't be using it. I just kept it for your reference. So these two files, these two IPython notebooks we'll be using. This is my solution, and this is a code template I provided for you to solve. So let me show. If you go to PySpark, if you go to project, so this is a code template. I already wrote the questions for you. You don't have to write them again. Just write the code. Just simply write the code, and also provided my solution. Is my solution. There are multiple ways to solve one problem. So if you're solving a different way, my solution is different. It's okay. As long as we're getting the right answer, the approach doesn't matter. Okay, let's import this in Databricks Community Edition. Go to Databricks Community Edition. I will also provide this link. So simply sign up or sign into Databricks Community Edition. Simply go to Workspace, create a folder. So simply create a folder. Let's give a name, Northwind PySpark project. PySpark, yeah. Create. Then again go to, we don't have to create a notebook. So let's import the code template. Go to these 3 dots, import, and then browse, and go to the location where your file is located in your local system, and then import it. Then import. So the file is imported. So okay, remove this. You don't need this. Okay, let's go to data. Let's import the data too. Go to catalog. Simply go to catalog. Create table. Create table. Okay. Then browse. Go to data. Okay, just import all of this. So once you import the files, copy this path, Control C, and then go to our notebook. Yeah. Then paste it. You need these file paths while importing the data, while loading the data. And then one more thing. Now we need to create a cluster. We need to connect the cluster to run the commands. Go to compute, create compute, give it a name. Let me give Northwind itself. Northwind. Let's go to 15.4 LTS and then create. So it will take a while to create. Then go to workspace, go to the project. So once the cluster is created, you can connect it here. So now that we already have the project context, let's focus on building the code. It first will be importing the libraries, and then we'll be loading all the data, and then we'll be working on all the questions one after the other. So let's first import the data. Okay, I already connected the cluster. As you already know, I created the cluster Northwind, and then I connected the cluster here. Let's focus on import the libraries first. So from PySpark dot SQL dot functions, import everything. From PySpark dot SQL dot types, import everything. The star means import everything. From PySpark dot SQL dot window, import window. This is to import window functions. We'll be using quite a few window functions in this project. Okay, so yeah. So we imported the libraries. Then let's load the data. So as you already know that we have the file paths here. So let me delete this. Okay, let's import the products table first. Let's get the products path. Control C, and then here let me save this in a variable products path equal to control. Yeah. Then let's load the data. Let's read the data. Spark.read.format CSV. This is a CSV file, and then dot option. The first column contains the column names. So let's say the header is true, and then option. Then let's also insert the schema rather than creating manually providing a schema from our side. True. Then let's read it. Load products path. Let's run it. We got the data. So let's store this data frame in a products variable, and then let's display the data. Take the code. Yeah, products dot display. So we can clearly see there are 77 rows, which means 77 products in this products table, and then we have quite a few columns. Okay, now let's load the remaining tables. Let's take this. Let's copy this code. Control A, Control C, and then Control V. Let's change the products to orders, and then here also Control C, and Control V. Here it's orders, and then even here it's capital O and orders. Yeah. Orders dot display. Okay, we got the orders table. Okay, let's follow the same for remaining three tables: customers, employees, and suppliers. Let me copy it. Control A, Control C, Control V, Control V, and Control V. Okay, by now you know the drill. Employees, employees, employees path, employees. Let's run it. Employees dot display. Yeah, we have 9 employees in this dataset. Suppliers, and then Control C, Control V, Control V, remove the path. Suppliers. Let's start here itself. Suppliers dot display. Okay, we got suppliers, we got the employees, we got the we did not change the customers. Okay, let's load the customers. Customers, customers, customers. Now let's copy this variable, control C, customers path. Yeah, customers dot display. So now that we imported the libraries and data, let's focus on solving the problems. I also expect you to go to the data and the schema on your own. The first question is, how many current products cost less than $20? So let's display the products data. Products.display. And also one more thing, the first five questions will be related to products table. So if in products details, in products table we have product ID, product name, and then if you want to know the unit price, we have a if you want to know the price, we have a unit price. And also we have something called discontinued. Discontinued shows that if the product is being shipped right now or not, or did the company stopped shipping those products. So we want to know the current products. Current products means should not be discontinued. So let's write simple filter condition for this. Products dot filter where the product's cost should be less than $20. So unit price should be less than 20, and also the product should not be discontinued. So call of discontinued should be false. So let's put this in a bracket, otherwise it won't work. This in the product so now display. So we have basically we have 37 products which are less than 20, and also we are currently shipping those products. Yeah, that's it. Simple filter condition would solve that problem. Now let's go to the second problem. Which product is most expensive? So again, products products.display. Again, it's a filter condition. It's very simple. No, so again we'll be using the unit price. We can simply sort the unit price in a descending order, and then we can take out the first product, which is the most expensive product. Simply you can sort by unit price. Products dot sort, and sort by default it's ascending order, so we need to specify the descending order explicitly. This in DSC, it's short for descending order, and then the column unit price dot display. So yeah, so the most expensive product costs $263.5, and then we need to limit it to only the first one. So dot limit one, sorry one, and then display. Yeah, the product number 38 is the most expensive product. So let's see the third question. What is the average unit price for our products? So products dot display. What is the average unit price? So basically simply aggregate over the average price, we get the result. So average products dot aggregate, and the aggregating function is average of unit price dot display. So yeah, let's also change the column name. You can simply do alias average unit price. So yeah, we can also okay, there are too many decimals. Let's simply round off. comma 2. Yeah. So yeah, $28, 28.87. So basically $29 is the median price, median unit price. So let's go to the fourth question. How many products are above the average unit price? The previous problem we solve the average unit price, which is 28.87. We need to find all the products that are above this median product, above this average unit price. So let's save this. Okay, we can simply hard code the value average unit price equal to 28.87, or we can also directly collect it from here. Let's collect this from here. Let's take this control C. So let's save this result in a variable we want to display. So you can simply say average unit price equal to, but again okay, let me show you the problem here. So we are saving it in a data frame, so we cannot we need a number. For that we need to collect the value. We need to perform a collect. So we collected the value. It's in a, but we can, the value is in a list. So we need to get out of that list, and then the value average unit price. So yeah, so simply what we did here is this will result in a data frame, and then we need to collect that from a driver node to worker node. So we need to collect the information from the driver node to worker node by using collect, and then this is in a list. So we get out of that list, and then we get the price, we get the value 28.87, right? So now save this in a variable average unit price. Now we have to filter out the products that are that are greater than this. Products dot filter column of unit price. Column of unit price should be greater than this average unit price. Greater than average unit price dot display. Done. So we have 25 products. So basically in total we have 77 products. So let me also show it here. Products.count. Products.count. So we have 77 products, and from that the products that are greater than the median unit price or the average unit price is 25 products. 25 products that are greater than the average unit price. Okay, let's go to the fifth question. How many products cost between 15 and 25, and including 15 and 25? Products dot display. I generally like to see whole data at first. So again, it's the same unit price, which should be greater than 15 and less than 25. Products dot filter column of unit price should be greater than or equal to 15, because it's inclusive, it mentions inclusive. And so let's put this in a bracket, and column of unit price should be less than or equal to 25. Put this in a bracket. So the product should satisfy both these conditions. So display. So we have 25 products between this price range. You clearly see, let me sort it here. So 15 is the minimum, and then if you go here, 25 is the maximum. So 25 products are between 15 and 25. Okay, and let's go to the sixth question. What is the average number of products per order? From here, from 6 to 10, we'll be using orders table. So per order, So the question says, for every order, how many products were brought? So for example, if you go to a supermarket and you don't if you're buying only one product, which means for that order there was only one product was bought. So if you're buying five products in that one order, so the number of products you bought was five. So if you add both of these, five plus one, and average is, so an average you have brought three products. So that's what they're asking. The what is the average number of products per order? So let's go to orders table. So if you look at, okay, let me order sort this. So if you look at, for example, this order, 10248. So there are three products because this orders table is in product level. Let me show it here for you. So you can see for that 10248 product order, there are three products, product number 72, 42, and 11. These three products were brought. So likewise, we need to find how many products were brought for every product. So sorry, how many products were brought for every order, and we also we find the what is the average number of products per order. There are two steps here. First, let me write it here. First, we need to find how many products were brought per order. And the second question is, what is the average number of products per order? So let's solve the first part of the question. So orders dot group by on orders order ID dot aggregate. Let's count the number of products per order. Count dot display. So okay, let me sort this. So you can clearly see for 10248 we have three products. So likewise for every for every order there are these many products were brought. And now we need to find what is the average number of products per order. Okay, let me also change the column name here. Dot alias product count. So let me display it. Yeah, product count. Now for this product, let's save this in a variable product count equal to, let me remove this display. Yeah. So now this product count dot display. Yeah, now we need to find average of all the products. So dot aggregation average of product count dot display. So yeah, okay, also let's round it, round off, comma 0. Yeah, and also let's change the column name. Dot alias average product count. So on average, for every product, for every order, there were three products were brought on average. So that's a solution. So now let's focus on seventh question. What is the order value in dollars of open orders? So let's go to the orders table first. Orders dot display. So in this we have three date tables: required date, ship date, and also order date. Yeah. So order date shows on which date the order was placed, and then they required that order between before this date, and also the ship date shows when did the order was shipped from us. So we need to find the order that were not shipped yet. So basically we need to find orders that were where ship date is null, which means we did not ship the product yet, but the order was placed. Now we need to find the order value of that. So order value shows here. So we can clearly see the how many the quantity, how much quantity of the particular product was placed, and also the unit price of the product. So we can clear, and also we have simply have a sales table, which simply which is basically unit price into quantity. So we need to find the total order value of the not shipped products. So there are two steps in this problem. One, filter out the products, filter out the orders that weren't shipped. Next, calculate the order value of those orders. Let's first filter out the not shipped products. Orders. So not shipped orders. Again, I'm confusing between orders and products. Orders dot filter column shipped date. It should be not null. So basically it should be null. Is null dot display. So there are 73 orders, not exactly orders, because it's also duplicated, because it shows per product. In these orders are showed in a product level. So there are 73 rows. We have 73 rows of, so we have 73 products. You can clearly say that we have 73 products that were ordered but not what shipped, but weren't shipped. And then okay, so we can clearly say not shipped, not shipped equal to, let me remove this, not shipped dot display. So yeah, 73 products. Now we need to find the sales value, total order value. So basically simply aggregate this sales value, aggregate this sales column, and we get the order value. Dot aggregate sum of column underscore sales dot display. So this is the order value. Let's also, let me change the name, alias order value. Yeah, and also let's also round it. We don't need these many decimals. Round comma 0. Yeah, $27,444. That's the answer. Now let's go to 8th question. How many orders are single item? Only one product order. So let's go to orders table dot display. So we need to find orders where only, so basically we need to find all the orders, the number of orders where only one item was placed. Now clearly we can, okay, let me show it here. Previously we solved how many orders were placed here in this. Here we can see here we already solved the, for every order how many products were placed. So we need to filter. So okay, let me write this. Let me show this. Products, product count dot display. So for every order, these many products were bought. So we are asking, it says how many orders were placed where only single item was placed, which means the product count should be only one. For example, this product, for example, this order. So 10914, only one product was placed. dot. So basically we need to filter out, filter column of product count equal to 1 dot display. So basically there were, in total there were 830 orders were placed, and then from that 137 orders were single item orders. So these many orders were single item orders. So okay, now let's go to the ninth question. Average sales per transaction for Romero y Tomilo. So basically Romero y Tomilo is a ship name. Okay, let me show it here. Order again. Let's go to simply orders.display. Yeah. So if you go to, there is a ship name, and then if you find Romero y Tomilo, there is it. So yeah, okay. So as I already told you, the ship name. So Romero y Tomilo is a ship name. You can clearly see here. So we need to first of all filter out the uh, filter out the ship name, and then we need to find the average sales per transaction. So the first step, let me write the first step. There are multiple steps involved in this problem too. So let me write the first step. Filter out the ship name. So orders dot filter where column of ship name equal to Romero y Tomilo dot display. So we have 14 products. So we have 14 rows in total where the ship name is Romero y Tomilo. From that we need to find the sales. So order value for every order, for every transaction. So first of all, we need to find the uh, sales per order, because this table wasn't in order level. So we need to find, first of all we need to bring it to the order level. So we need to find the we need to group by on order level, order id level, and then find the sales amount per order. We'll be using order id column, and also I already shown you, at last we have a sales column, sales. So we'll be using these two columns to get the sales value per order. Okay, let me store this in a variable Romero. Yeah. Then Romero's orders. Romero dot group by on order ID, and then order ID capital. So it's ID. Yeah. Dot aggregate sum of sales. It's capital S. Capital S. Dot display. So there are 5 orders placed from Romero from the ship name, and then this is a sales value per order. And now it's asking what is the average sales. Average sales. So first of all, let me rename this column. It's quite ugly. Dot alias sales order value, simply order value. So let's also store this in a variable order value equal to, we remove this display, and then order value dot display. So now finally we need to find the average order value for all the orders. So average order value. So order value dot aggregate average of order value dot display. So on average $293.45 from the Romero ship. Okay, let's also alias this average order value. Yeah, average order value. Let me remove this order value dot display. Okay, we can also round it. It's waiting. So let's also round it. Round comma 2. So yeah, on average, the average value. So basically, the average sales per transaction is for Romero is 293.46 dollars. So let's go to 10th question. How many days since north or south sales last purchased? So what? So basically, we need to find the what is the last order date. Okay, last time. So basically, we need to find the last transaction order date, and then we need to compare it with the today's date. So basically, for this solution, yours value and my value will be different because the current date is different. So let me show it here. First of all, the north south is a ship name. So basically, actually the north south is a company name. Though company name details will be in the customers table. The company name details will be in the customers table. So let me show you the customers table dot display. So north south company name. You can clearly see here the north south. So the north south. So there are two ways to solve this. One, you can join customers and orders table. So there are two ways to solve this. Either join the customers table and orders table and filter it out for the north south company name, or also simply get the customer id from customers table and filter it out in the orders table using the customer id. So first of all, let's get the customer id for the north south from the customers table. So customers dot filter company name. Company name. We need to put this in a column. Call equal to. Okay, let me copy this. Not so copy. Also paste it here. Control V. Yeah. Not south. Dot display. It's not capital C. Small c. Okay, now let's solve the 10th question. How many days since North South last purchase? So the question says, what was the last purchase date, last order date by the company North South? So basically, North South is a company name, and the company details will be in the customers table. Customers dot display. So here is the company name, and one of this North South is one of the company name. So let me filter it out. Filter uh, column. Okay, let me remove this display first. Column company name equal to north slash south. So remove the extra bracket here. Dot display. So yeah, as I said, the north south is a company name. This is the north is the customer ID. So here there are two ways to solve this problem, because we need the last purchase date, the last order date or the transaction date by this company. It will not be here in the customers details, customers table. It will be in the orders table. So there are two ways to solve this. One, join the orders date, orders and the customers table by customer ID, because customer ID is common in both orders table and the customers table. Or second way is to get the customers table, customer ID from the customers table, and save it in a variable, and then use this customer ID on the orders table and filter out the details, filter out the orders filter out the orders made by the particular customer ID. I will choose in second method. I won't be joining the orders and the customers table. I will be choosing the second one. So let me get the customer ID. So let me get this. So let me first of all get this. Control C. Dot display. And I only need the customer ID. So let's select the customers table, customer ID column. Again here we got the customer ID, but it's in a data frame. We need the value. So for that we need to collect it. So collect. So sorry, collect does not have a display. You can directly see the value. So we collected the value. It's in a list. So we need to get out of this list, and then now we need to find. We need to collect the value from the customer ID. So customer ID. Yeah, we got the value. Now save this value, customer ID, and display the value. Let me display the value. Yeah. Now we got the customer ID. Now filter this customer ID in the orders table. Orders dot display. So yeah, we have the customer ID here. Let's filter it out. Let me remove the display, filter, column, customer ID equal to customer ID dot display. So these are so basically we have six orders. Six orders were placed by this company, by the company North South. So let me write it here. The step one, filter out the orders made by the North's customer ID. Customer ID. Yeah. Now from this we need to find the last purchase date. So basically last order date. So basically simply we can sort the order date and get the and in the descending order and get the first order. So basically we can simply, okay, let me write it here. Let me save this in a let me save this data frame. Nots orders equal to, yeah. Now we need to remove the display. Now we need to sort the order date in the descending order and get the first order and get the latest order date. Basically nots order dot sort descending based on the order date column, order date dot display. So yeah, and we need to limit it for the first order because we need the latest order. Limit to first order. So this is the latest order. The last order was placed on June 12th 2024. So let me save this in a variable latest order. Remove the display, latest order dot display. Yeah, and from this we only need the order date, and because and now we need to compare this order date with the current date. Current date is today's date, and we need to find the difference of these dates. So basically we get the answer will be number of days since the last order, and this date will be, the answer will be different for both of us because the current date changes for me and for you the current date is different. So here itself let me select only the customer customer ID and the order date columns, and then let me display it here again. Now let's add the current date to this data frame and find the, okay, let's just add the current date. For that for to get the current date, today's date, we have a function called current date. So let's add that with column. Let's add that column. Column name is current date and then current date. That's a function dot display. Now we need to find the difference between these two dates. Current date added. So okay, okay, let me save this in a data frame. Current date added. Now we need to find the difference between last purchase date and the current date. Further, we have a date diff function, date difference function, and that will result in a number of days. So current date added dot with column date uh, difference in dates, difference in days. So basically date diff column date diff. So current date, column of current date, comma, column of order date dot display. So we have 101 days since the last order. For you it will be different, it will be more than 101. So the last order was purchased 101 days before today's date. So that's a solution. So we have multiple things. We did multiple things here. At first of all we filter out the data, and then we sort the order date in the descending order and got the latest order, and then we add the current date, and then we find the difference between the last purchase order and the current date. So let's this is the third one, and then that's the fourth. So yeah. Okay, now let's solve the 11th question. How many customers have ordered only once? So the order details will be in the orders table. You already know that. Display. So here is the tricky part. Okay, let me show you. Let's just select the only the relevant columns first. So okay, let me remove the display. Order ID, comma, customer ID, and the product ID. Yeah, display. So okay, we got the result. Orders dot select. We selected only three columns: order ID, customer ID, and the product ID. So here the question is, we need to find the customers who only ordered once, but the the table or the data is not in the customers level; it's in the product level. You can clearly see. Let me sort this. So like this is the order ID, and this is the customer, and the customer brought three products, and this is only one order. This is only one order, but the customer bought three products. So first of all, we need to make this data in such a way that we get the customer details, which should be in a customer level. At this present, it's in a product level. We need to get first in a customer level, and then on that, we need to find customers who only brought once, who only ordered once. So first of all, let's get this into a from product level to customer level. Okay, so getting the data from product level to customer level. So basically, we need to find for that particular order by that particular customer how many products were brought. First, we need to find that orders dot group by on both levels, order ID level and the customer level. Customer ID dot aggregate. We need to count the number of products were brought by that customer for that order ID. So we need to count the product ID. Product ID. Product ID dot display. So let's just comment this and then display. So we have, okay, let me also alias this. It's kind of ugly. Alias product count. So we need to find how many orders were placed by this particular customer. So okay, let me product level. So let me remove this first. Let me save this in a save this data frame in the product level variable dot display. Okay, now we need to find the we need to aggregate again and find how many times the customer placed the order. So group by on we need to find how many times every customer has ordered. So we need to group by the data based on customer ID, and then count the order IDs. Count the or aggregate. You can clearly simply write the count. Let me aggregate it. I don't like the count. Count on order ID dot display. So every customer. These many times this customer placed the orders. So this is the alias order count. So order count. Now we need to find order count where order count is only one. The customer placed only once. So let me save this in the order count variable, order count dot display. Let me display it again. Let me display it again. Yeah. Now we got the result. Now we need to filter where order count is only once, which means that that customer placed the order only once. We don't care how many products were placed within that order. We only care about the orders. So only the customer ID is CGNTC. This is the only customer who placed the only one order. All the other customers placed more than one order, maybe two or more than that. This is the only customer who placed only once. So yeah, customer with only one order. Let's remove the display. Customer with only one order dot display. Filter where orders were placed only one order was placed. Filter customers. Yeah, so basically, okay, let me summarize it again. At first, the data is not the data is in a product level rather than the customers level. So we need to first bring the data from the product level to customers level. So we performed a group by on both the order ID and the customer ID, and we got the for every order by that customer how many products were made, how many products were ordered. So now that we got the data from the product level to customer level, we aggregated our group by we performed the group by again and got the number of orders that placed by that particular customer, and then we filter it out. Here we filter it out where the customers only we filter out the customers who placed only one order, and then we displayed the order. We displayed the customers. So it's only one customer, and all the other customers we have placed ordered more than once. So that's it. That's the solution for this question. Okay, now let's solve the 12th question. How many new customers in 2023? Okay, let's get the orders details first. Orders.display. So here we need to find the customer who are new in 2023, which means whose first order was placed in 2023. So for that, okay, let me get the relevant columns first. So select order ID and customer ID and the order date. So these are the relevant columns to solve this problem. So display. So okay, let me write it here. So select the relevant columns. Now, now because we already know that orders table is in the product level, not in the orders level. So here if we let me sort this here. So if you see the same, so the same order ID is duplicated three times and the customer ID and also order date. because this customer for in this order id brought three products, so we don't need the products level. That's why let's get the only distinct rows. So the distinct or display. So in total we have 830 actual orders. So and get the distinct columns, see distinct rows or distinct orders. Yeah, let me set in the next line. So now we need to find the, okay, let me remove this. Now we need to find the customers whose first order was in 2023. So let me save this first. Order details equal to, yeah, and then order details dot display. Okay, for this, okay, to find the customers whose first order was in 2023, let's just rank the orders by every customer. So for that we need a window function. So if you, so let me show you this. Window equal to window dot partition by customer id dot order by the order id, order date, and then here dot with column, let's rank the orders by the order date. So order rank, a rank function ranked at over the window frame we specified dot display. So the partition by, there is no capital P, okay, small p, yeah. So we clearly see, but this is the customer. This customer placed 6 orders, and then and it's ordered by the order date. So the first customer, the customer's first order was in 2023 October 9th, and the last order was in uh, May 23rd 2024. So we ordered in the ascending order. So now, okay, we got the order ranks. Okay, let me remove this display. Here we created a window frame, create the window frame, and rank the orders by order date in ascending order. Now filter out from this, we need to filter only the first orders, and the first order also should be in, the first order should be in 2023. That's where we get the new customers, 2023, yeah. So order ranks dot filter column or column order rank should be 1, and also, okay, and also we need to have the year of the order date. So year of column of order date should be 2023, should be 2023, yeah, equal to 2023. So we need to embed this condition in a bracket, and also should be, this should be in the closed bracket. Let's start display. So okay, so uh, this customer id placed the first order in 2023. All these customers placed their first order in 2023. So these are all the new customers. So in total we have 32 new customers in 2023. that's it. Okay, let's solve the 13th question. How many lost customers in 2023? So orders dot display. So we need to find the customers whom we lost basically in 2023. After that, which means after 2023, they did not place any order for us. So the customers, the last order should be within January 1st, 2023 and December 31st, 2023. If the last transaction order was in this period, that means we did not see any, we did not see that customers order in 2024, which means we lost that customer now. So let's see. Okay, again let's also select again same. Let's select the customer ID, only relevant columns. Okay, let's just copy the code from here itself. We'll just get this order details, order details dot display. Okay, now let's rank the orders by the order date. But so here in this case, compared to previous case, we need to rank the orders in the descending order because we need to fetch out the last transaction order they made. So let's create the window equal to window dot partition by customer ID dot order ID in the descending order. We need to find the latest order should be the rank one, descending column of order date. Now let's create the new column and rank the orders. So order ranks. Okay, so let's get the order details. Details. Yeah. So let me remove this display. Yeah. Order details dot dot with column order rank. Again same order rank, and then rank the orders over this window dot display. We can clearly see this customer's last order was in 2024. So this customer is an active customer for us. The customer who placed the last order was in 2023. That's a lost customer for us. So now, okay, let me write here to uh, create the window frame and rank the orders in descending order by order date. Now let's filter out. Okay, let me save the result in the order ranks data frame, order ranks variable. Okay, order ranks dot display. So here also we need to only fetch the order rank is 1 and the order date should be within 2023. Okay, now let's display the order ranks dot display. Okay, now we need to find, we need those customers whose last order was within 2023. So filter basically dot filter column of order rank should be 1 and year of column of order date should be 2023. And let's put this condition in a closed bracket and also this in a closed bracket dot display. So can we write what we did here? filter the filter the orders where order rank is 1 and year is 2023. So we lost these customers last order was in 2023, and these customers did not place any order in 2024 for us. So which means we potentially lost these customers in 2024. Okay, now let's solve the 14th question. How many customers has never purchased Queso Cabrales? So basically Queso Cabrales is a product name. Product name Queso Cabrales. So we need to find the customers who never purchased Queso Cabrales. So for that, the details, first of all we need a product ID for that, and we need to filter out the product ID in the orders table. So let's join the two tables and then directly filter it out using the product name. So orders dot join. So okay, at first let's join the two tables. One, okay, join orders and products table, products on product ID, and then perform a inner join using inner join. So orders dot orders dot join. So capital O, small o, okay, and products on product ID, how inner join dot display. Okay, so we have all the details of order details, and also we have relevant product details. We have product details. So now let's filter out the filter only the Queso Cabrales product name, and filter column of product name should be Queso Cabrales. So filter the rows where product name is Queso Cabrales. Yeah, dot display. We have 38 rows. 38 times Queso Cabrales was ordered, and we need only the customers who ordered them. Customers, and sorry, select customer ID. Again, a customer might have purchased Queso Cabrales multiple times. So let's only get the distinct customer ID. So let me show it here. So Anton, the customer ID, bought the Queso Cabrales two times. So we need to filter out only the distinct one. So distinct customers. Yeah, so in total we have 32 customers who brought the Queso Cabrales. Again, but the question is not who brought the Queso Cabrales, who never bought the Queso Cabrales. So we need those customers who never bought this product. So let me write here what we did. So select only the customer IDs, sorry, distinct customer IDs. So to get the customers who never bought this, we need to go to customers table. So let me save this. Customers purchased Queso. Let me save this in that variable. Let's remove this. Okay, let me remove this. Yeah. Now the display. So as you know, these are the customers who bought this product. Okay, let me show you the customers details. Customers.display. So in total we have 91 customers. Out of that 91 customers, 32 customers bought the Queso Cabrales. So remaining 59 customers did not bought the product. So we need to fetch those customers. So for that we can simply perform a left anti-join on customers with the customers purchased Queso on this data frame, and then we get those results. So let me show it here. So let's join customers who purchased Queso on customer ID, and the join type is left anti. So left anti join generally gives the products that were not common within those, and only gives the left side, left table. So so the left table is customers. So you'll only get the details of those customers who never purchased this product. Let me also display the result for you. So we can clearly see we have 59 customers, and these are all the customers who did not bought the Queso Capitalist product. That's it. So again, let me write the what we did. Step 4: perform a left anti join on customers who purchased the product to get customers who did not purchase the product. Customers who didn't purchase the product purchased the particular product. Here in this case, it's Queso Cabrales product. Yeah. So we have 15 customers. Okay, now let's go to okay, now let's solve the 15th question. How many customers have purchased only Queso Cabrales per order ID? So basically, so for a particular order ID, we need to find those customers who only brought one order, and then that one product should be Queso Cabrales. So here there are two things here we need to solve. One, customers who bought only one product, who ordered only ordered one product, and then that particular product should be Queso Cabrales. So there may be multiple customers who only brought one product, but that might not be the product name we are looking for. So that might not be Queso Cabrales. They may have bought only one product. That can be any other thing other than the Queso Cabrales. So we need to find the inner join between those. So we need to find the data frame where customers only bought one product, and also we need to find the customers who only bought Queso Cabrales, and then we need to find the common customers who only bought one product and the Queso Cabrales. So let's solve this first. So let's solve the first condition. So if you go to orders table. So we need to find the customers who bought only one product. So for that, so first of all, the orders table in a product level, we need to change it to the customers level first of all. So group by on order ID. Okay, we did something similar to this previously. Customer ID dot aggregate on, and they count the number of products were bought by that customer for that order dot display. So yeah, and okay, let's also change the column name here dot alias product count. So yeah, so this customer in a particular order only brought one product, so we need to fetch something. We need to fetch all these orders but the product count is only one. So for that we can simply perform a filter condition dot filter where product count equal to 1. So yeah, we have these customers. Now that from this we only need only the customer details, though customers ID, and then we need the distinct customers. Distinct. So yeah. So these are all the customers who only bought one product for a particular order. So customers with one product. Let's remove the display. Yeah. So we solve the first condition. So let's solve the second condition. Control X. Yeah. So we need to find the products. So we need to find those orders where the product was only quasi capitalist. So orders dot that quasi capitalist is the product name. The product name is in the product details. So let's join this with the orders and products. So orders dot join products on product ID, and then how it's inner join. Let's display. So let's display. Yeah, here you can clearly see we have all the products, and then from this we need only those products where the product name is quasi capitalist. Filter column product name should be quasi capitalist. So we have 38 times this product was ordered. You can clearly see. Yeah, here you see, we can see. Let me show it here. Product name quasi capitalist all the times. So from this we need to fetch only these customers. So select customer ID. Again, customer ID might be in both products and orders. So let's just get from the, so we don't want to get the ambiguous error. So customer from the orders table, customer ID dot display. Yeah. So these are all the customers. Again, there might be a customer might have brought the same product multiple times. So let's just get the distinct customer IDs. So we have 32 customers who brought the quasi capitalist. So we write, let me write here. Let's save this in a variable customers with quasi. So now I have two data frames. We need to perform inner join on this and then get the common customers who brought only one product, and that one product is quasi capitalist. So customers with one product dot join. Here let me see, it's customers. Yeah, customers with quasi, and perform the join on customer ID, and then how inner join, and we will get those customers who satisfy both of these conditions. So let's also display the result. So these are all the customers. Okay, let me see, are there any duplicates? Okay, we don't have any duplicates because we already performed a distinct. So these are all the customers who brought only one product in a particular order, and that product is quasi capitalist. So we have in total 28 customers. So yeah, that's it. Okay, now let's solve the 16th question. And for the next couple of questions, it deals with products and the stock levels of every product. So let me show it here. If you go to products table, display. So this is a product ID. And then if you go to here, so if you go here, we have three columns: units in order, sorry, units in stock, units on order, and the reorder level. So basically, units in stock says at this particular time how many products are left with us. We have how many products, and then units on order shows how many products customers ordered for a particular from a particular product. How many customers ordered the product. So that shows the units on order, and the reorder level is basically a threshold level. So basically, if we go beyond this threshold level, we need to reorder those products from the suppliers. So let me show. So now, okay, now we know the context of this. Let's solve this question. How many products are out of stock? So basically, out of stock means we don't have any of those products now. Which means if a customer ordered the product, we cannot deliver that product. So we need to find those products where we are out of stock completely. So units in stock. So products dot filter column units in stock equal to 0 dot display. So out of 77 products, 5 products we are out of stock again, but this may not be the correct answer, because if you see the discontinued, we discontinued 4 products from that. So we really don't care whether the out of stock for those 4 products is 0 or not. But again, in the question, it did not ask the current products. If it's the if how many current products are out of stock, it's it's one, because only one product is being shipped, and then we did run out of those products. We did run out of that particular product. But here we did not have any question related to current products. So there are total 5 products we run out of stock. So yeah, next let's go to 17th question. How many products need to be restocked based on the restock levels? I say restock levels is related to threshold level. So products dot display. So yeah, if we go to units in stock and the reorder level. So so only, okay, when do we restock? When the units in stock is lesser than the reorder level. So if we say the filter, so basically column units in stock should be lesser than or equal to column reorder level. That's when we order those products dot display. So we have 22 products where we need to reorder immediately, otherwise we will be run out of stock. So these are the products where we need to order immediately from the suppliers. Otherwise, when the customers order these products, we cannot supply them. Okay, now let's solve the 18th question. How many products on order we need to restock? So basically, customers ordered those products, but we don't have in stock. So we need to find those products. Products dot display. Basically, if I show here, the units in stock is 39. We have 39 products. So here, let's take this product number 2. So we have in stock that 17 products, but on order we have 40 products. So 23 products, we have less than 23 products. So we need 23 products to fulfill these orders. So we need to find those type of products. Filter column units in stock should be less than units units on order. But also we need to satisfy another condition, because here we can see the number of orders are 0 and also stock is 0. So the order number of orders should be more than 0, and column units on order should be greater than 0. Let me put this in a bracket, and symbol, not the and letter, dot display. So we have in total 14 products where the order the amount of order is higher than the stock. So we cannot fulfill these orders if we don't restock immediately. So yeah, that's the answer. 14 products. Okay, now let's solve the 19th question. What is the stocked value of the discontinued products? So basically, okay, what we want to know is we discontinued for products, and but we have those products with us. We want to know what is the loss, what is the order value of those discontinued products. So products dot display. So at first we want to know the products which are discontinued. So which means discontinued should be true. So filter column discontinued should be true, and then display this. So out of 77 products, we have 8 products that we discontinued, but we have the stock. We have for this. Okay, if you take this product, we stopped selling this product, but we have 26 products left with us. Now we need to find the uh, now we need to find the order value. So basically unit price into units in stock, that gives the, and summation of that gives the total order stocked value. So column stocked value of the product, stocked value of the particular product is column of unit price multiplied by column of units in stock. So we have, so this product, the stock value is $2,813. So we need to summation, we need to perform summation on this to get the total stock value of all the discontinued products. So let me do this. So summation on this dot aggregate sum of stocked value, sum of column of stocked value. Yeah. So we did not forgot to add the slash. So in total we have $4,452 of loss, because we have those products but we are not shipping them. So that's a loss for us. So let me also rename this dot alias total stocked value. Yeah. Okay, let's solve the 20th question. Which vendor has the highest stock value? Vendor is basically the supplier. So okay, let's get the data first. Products.display. Okay, let me get the relevant columns and then we'll solve the problem. Select product ID, product name, supplier ID, and then unit price unit price, and then units in stock. So here we can clearly see at present we don't have a stock value. So for stock value is basically the unit price and the quantity. Units in stock here is a quantity, amount of quantity of that product we have at this point of time. So let's calculate the stock value first, and also this table, this data from is in products level. We don't, but we want the stock value or the supplier who has a high stock value. So we need to convert this data from a product level to a supplier level. So we need to perform a group by. So there are multiple steps. Okay, let me do one. Let's solve one after the other. So first of all, select the relevant columns, products, product level. Save this in a product level variable, and then level lgbg. Yeah, now we need to get the stock value, get the stock value at the product level. Yeah, product level dot with column. We need to add another column, stock value. Column name is stock value. So basically multiplying the uh, units price column and the units in stock at row level. So we will get the stock value by product. Let me display it. So we got the stock value. Stock value of this product chai is $702. That's the amount of product value we have right now, or the stock value we have right now with us. So let me store this in a variable product stock value, and then we need to convert this, or we need to transform this product level data into a supplier level data. So uh, transform the product level data to supplier level data. So for that we have to perform a group by over the product stock value, supply the product level data to a supplier level. We need to perform a group by on supplier, group by on supplier id dot perform aggregation, or some perform a aggregation or summation over the supplier id on the stock value dot display. So yeah, let me change the column name dot alias supply. This is supplier stock value. Okay, sorry, it's not comma, it's dot. Yeah, yeah, we have the now we got supplier id and the supplier stock value. We need to perform a we need to find the highest one. So we need to perform a sort. We need to sort the data, sort. So we need to explicitly provide the descending order supplier stock value dot display. So for us, okay, the stock value is $5,721 and supplier id is 18. So we need to own this. So this is the highest supplier id. So let's limit the result to only one supplier because we need the first one dot display. So yeah, now if you want to know so we have the supplier id, but we want to know supplier details. We need to go to suppliers table. So let me save this result. Highest supplier, in highest supplier, highest supplier, and let's join this data frame with the supplier's data frame on this supplier id. So suppliers highest supplier dot join suppliers on supplier id and how inner join. We only need this data, or we only need this particular supplier. Let's also display the result. Display. So this is a supplier with the highest stock value. Okay, that's okay. Let's go to next question. How many employees are female? So and the next set of questions from 21 to 25, it deals with employees data. So employees dot display. Okay, employees dot display. So we have in total 9 employees with us. So we need to find the how many employees are female. So it's very simple. Just filter out by gender. We have a gender column. Gender. Let's write the column of gender. Column of gender equal to female dot display. So we have 5 rows. So basically we have five employees. Out of 9 employees, 5 employees are female and 4 employees are male. That's it. Okay, let's go to. Okay, now let's solve the 22nd question. How many employees are 60 years old or over? So let's go to employees data first. Employees dot display. So if you see, we don't have a age column directly. So but we have a birth date column. So basically we are going to use birth date, and we'll be calculating the difference between birth date year and today's year, and then calculate and get the number of years. So select. Okay, let me get only the relevant columns. Employee ID and the birth date dot display and now let's get the current date, today's date, with column current date. So yeah, we got the current date. Now we need to calculate the we need to get the difference between these 2 years. So with column age. So basically column of birth date. So it is sorry we need to embed this in a date difference function. Date diff column of birth date or the current date comma column of birth date slash yeah. So we get the age in days. We need to divide this. We need to divide this all of this by 365.25 to get the years. 365 by 2.2 by the 0.25 because we need to account the leap year. 0.25. Now we got the age. Okay, let me also round this and get the only 2. Yeah. So we have the age in years right now. Now we need to filter this condition. Filter this for only 60 years or older. Filter column of age where column of age should be greater than or equal to 60 years or older. 60 years or older. So greater than or equal to 60. So we have 8 customers, or sorry, we have 8 employees for 60 years or older. Yeah. Okay, now let's solve the 23rd question. Which employee has the highest sales in 2022? The sales details are in the orders table. So let's get the orders table. Orders dot display, and we clearly see employee ID and the amount of sales that person made within that order. So these are sales. So we need to get this data, and then once we get the highest employee ID with the highest sales, we'll join this employee ID with the employees table to get the employee details. So let's do that. First of all, we need to get this data into a employee level rather than the orders level. So group by on the employee ID and aggregate over the first of all we only need the sales in 2022. So we don't need to perform the group by. First of all, we need to filter the orders date, where order date is only in 2022. So first of all, let's filter this. Let me write this. Filter the records where the order was placed in 2022. So orders dot filter column of order date and year of column of order date equal to 2022 dot display. So in total we have 2155 rows. Now after filtering, we have 286 rows. So let's 22nd orders 2022. Let me write it. Let me save this data frame in a variable. Yeah. Now from within this, we need to find the highest employee. So perform a group by on this. Transform the order level data to employee level. So orders underscore 2022 dot group by on the employee ID and the perform a aggregation over or summation over the sales column, sales dot display. Now okay, let's also perform a round. Let me do a round on this round of the decimals, and also change the column name dot alias sales amount. So this is a sales amount this employee brought to the company. Now let's perform a sort to get the let's sort this data to get the highest sales dot sort based on the descending order based on sales amount. And then we need to only limit to the first employee, which employee had highest sales. So let's limit to the first employee. So employee number 4, so highest sales. So employee number 4 has the highest sales. So who is that employee? So let's join this data highest sales with the employees details to get those employees details. Uh, sorry, dot join employees on employee ID and how inner join. dot display. Let's display the result. So employee number 4, Margaret Peacock, was the employee who has the highest sales in 2022. Okay, now let's go to 2024. How many employees sold over 100K in 2023? Okay, let's also, okay, let's same, it's very simple to this. Let's get this orders 2022. We're going to change it to 2023. Change from this to 2023. So in total, first we have 2155 records, total records. And let's see how many records in 2023. How many sales were happening in the 2023. We have 1016 in the in 2023 year. Now let's get the, again let's also perform the group by over this on employee ID, but again aggregation over the sales column, and also let's display this. Let's also perform this round again. Let's see, let me copy this here itself, sales and control C, and change this aggregation, control V. Yeah. So and let's sort this, sort based on descending order to get the highest sales amount. Again, but we don't need the highest sales amount. We need someone, how many employees who made above 100K. So filter it. So we don't need the sort. You can simply filter it out directly. Filter column of sales amount should be greater than 100K, 1000, 10,000K, 100K. So we have only one employee, the employee number 4, which is the same employee. So Margaret Peacock was the highest sales employee in 2022 and also in 2023. So let's go to the final question. How many employees got hired in 1994? So employees data, employees dot display. So yeah, uh, in employees data we have a hire date. So we need to find the how many employees were hired in 1994. So basically filter column of hire date and simply the year of column of hire date. Going to get the year should be 1994 dot display. So we have 3 employees who were hired in 1994. So 3 employees. That's it. We solved all the questions, all the 25 questions. Thank you.